Hi, this is Mr. Ward. I'm going to be discussing the first three problems from problem set A. And so we've got this number one. We've got and I'm going to do this fast, so you can pause whenever you need to. The radius of A is 8 centimeters. I'm going to conveniently draw that to the point of tangency that we've got there and make ourselves a nice little right triangle. The tangent segment is 15 centimeters long. So which one's the tangent segment? Well, it's the segment that's tangent. So that's 15. That's 8, and we're asked to find the length of AC, and the Pythagorean theorem will get you that. Pause the video, see if you got that. You paused the video, didn't you? And you found out that this is 17 because this is a Pythagorean triple. Yay! Okay, number 2, concentric circles with radii 8 and 10 have a center of P. XY is tangent to the inner circle and is a chord in the outer circle. Okay, and so we want to find what XY is, and we're given a hint, which is to draw PX and PY. So you should pause the video. You should do that and see what you can come up with from that. I'm going to assume you are pausing the video, and now you're back, and you know that those two segments are 10, okay, and you know that this is a right angle because it's a point of tangency that we've drawn the radius to. We know that this side here is 8, and so ZY by Pythagorean triples. If you're still watching and you have not paused yet, pause now because you can find this now. Okay, you paused, and you know that this is 6 because Pythagorean triple. This is 6 because Pythagorean triple, because these two triangles are going to be congruent, and so that's 12. So 12 is the answer. Woo! 12 whatever units, we'll call them badgers today. Okay, number 3, given PR and PQ are tangents to circle O at R and Q, so there's the tangent. We want to prove that PO bisects angle RPQ. Okay, and they've given you a hint to draw RO and QO, or OQ. So we're going to do that. Okay, and hopefully you're starting to see what you can do with this. Pause the video and take note of what we've done here. I'll assume you pause, and I'm going to go right into it. Well, first of all, that's a right angle. That's a right angle. This is congruent to this because they are radii. This is congruent to this because they are they're two tangents from a single point to the same circle. And by Connor theorem, this is congruent to itself. And so that means we got two triangles that are congruent to each other by side, side, side. We could have stopped at hypotenuse leg since they're right triangles, or side angle side. Any of those would work. And Kappa leads us to those angles being congruent. Number 4, given AC is a diameter of B, and S and lines S and M are tangents to the circle at A and C, we want to conclude that S is parallel to M. All right, think about that for a second, and then pause the video and come back. You have paused and then come back, and you know that that's a right angle because that's a point of tangency that the radius is drawn to because the radius is part of the diameter. Same there. We have two lines that are perpendicular to the same line. They are parallel. That was one of the basic ideas and theorems in the parallel lines chapter. And that's it for the first part of A.